Okay, great. Hi, everyone. Welcome to the last session of this week for the Solana Hackathon. Today, super excited. We have the Elusiv team with us today, and Nico will be going through how to build private Dapps. So without further ado, Nico, go ahead. You can kick things off.
All right. Yeah. Thanks for the quick intro. Yeah. Let me share my screen then, and we can jump right into it. So, okay, I think that works. So, yeah. So, as Johanna said, my name is Nico, and I'm one of the core developers for Elusiv. For those of you who might not have heard of Elusiv before, here on our website, we have this nice little animation I'd like to use to explain what it is in 3 quick steps. The main idea basically is Elusiv is a privacy protocol on Solana that allows you to privately interact on chain, meaning that, as most of you probably know, on Solana, you generally have a public balance and your public key, and you can make transactions with that. But that has a disadvantage that basically everyone can follow that on chain. So using Elusiv and our SDK, which I'll show you in a second, you can easily make it private, so to say. Yeah. And the way it works is here with the little animation you can see, basically Elusiv allows you to create a so-called private balance. And as the name implies, this is a balance of assets that you can hold that aren't visible on chain, basically. And once you have those private balance, pretty analog to public balance, you can send privately from it and do lots of other cool things. And yeah, here we have step 3, stay in control. I'm not sure if that's really a step necessarily, but yeah, we also offer a suite of nice viewing keys and some other cool compliance tools. So I'll show you those in a second as well. Yeah, before we jump into the code, one last thing. The SDK that we're using today, you can find on NPM. So it's just at elusiv/SDK. And for those of you who want to learn more about Elusiv and how the SDK works and whatnot, you can go to docs.elusiv.io. But yeah, that's enough introduction talk. So let's jump right into the actual code, which is more interesting. So right from the get-go, when we have the Elusiv SDK, essentially it should be relatively easy to set up. The only key difference is that you have this thing here, as we can see, that we import from the Elusiv SDK. It's Elusiv class. And this is basically the heart piece of pretty much every Dapp that uses Elusiv, because it basically is what allows you to control and access your private balance on chain and perform private transfers. So the way you set it up is pretty straightforward. Basically, the first thing you do is you create a connection. I don't think I need to explain that. I think most of you are pretty familiar with that, just a connection to the Solana blockchain. Next thing you need as well is a key pair. In most cases, in most apps, you'd be using the wallet adapter for this, or an actual wallet. Of course, not the actual key pair. But for the sake of this demo, we keep our private key in memory, which is super insecure. But yeah, just for the sake of demonstration, all on DevNet, all fake money, so should be fine. Okay, and now what's different is here you might see to build our Elusiv instance, we need the key pair, or rather the public key, the connection, and to specify what cluster we're on. So this is DevNet or mainnet or whatever. And this thing called a seed here, which is usually not something you have in Solana programs. And the way you build this is basically you just take this seed message, and this is not something that you need to define yourself. This is something that we import from the Elusiv SDK. And this seed message basically is what you're going to encode as a buffer or as a byte array, and you're going to sign it using ED25519. ED25519, just for information, is just the standard thing from what Solana uses. So if you use a wallet and you just do sign message, you don't need to worry about whether it's ED25519 or not. By default, the Solana signing algorithm does the trick here. So you just sign that with your secret key, and then you have the seed, which you feed into Elusiv. And basically, once you have those things, you're good to go. And yeah, what the seed basically is, some of you might be wondering about that. It's basically just something we use as a base to generate the cryptographic parameters that we need inside of Elusiv to create your private balance and do private things, basically. I'm happy to talk a bit more about the cryptography a little bit later, if some of you are interested. Yeah, so we've created our Elusiv instance. Cool. But more interestingly is what we can actually do with it. So let's have a look. Let's get rid of this. Basically, the first thing we want to do, if we remember the little animation on the website, is we want to top up or create a private balance, so to say. And creating a private balance or topping up is basically really just converting a public balance, so normal assets that you might already hold on Solana, into a private balance. Yeah, and the way you do that is pretty straightforward. So the first thing you do is you create your elusive instance, like I showed on the previous, in the previous code. And then once you have your elusive instance, first thing you're going to do is you're going to say, okay, top-up transaction data is elusive.build top-up. Then you say how much you want to top up. Then you say what token type. Here you can see the little code suggestion. We support Lamports, USDC, and a couple of others so far, adding more as we go. And if you want your token to be added, yeah, you can just submit a PR to our code base. I suggest the token type. And then there's like two other parameters, but for the sake of simplicity, in most cases, you won't need these. If you're interested in what these do, you can just look it up in the docs and you can, pretty quickly find out. Okay, next, since this is basically just a normal Solana transaction that converts from a public balance to a private one, we need to do what we always need to do with normal Solana transactions, which is signing them. So I'm going to say partial sign, key pair, and so basically we've built our transaction, we signed it. So the only thing left to do is to send it off. So for that, we use the elusive instance again. And we say send elusive transaction, and we give it all that stuff that we just created a second ago. Okay. And now if we look in our code here, what it should do is it should print initiating top up, then it should top up with the token type Lamports and 1 billion Lamports. For those of you, most of you already know this, but 1 billion Lamports is 1 SOL. So what we're doing here is we're topping up 1 SOL. So it should initiate, like it should print it should do it, and then it should print out the signature of the transaction that performed the top up. Okay, so let's try to run this. npm run top up. Okay, you see initiating top up. And the first thing that we might notice here, let me make this a little bit smaller, is that this is unfortunately a little bit slower than if some of you have developed on Solana before, your conventional Solana transaction. The reason for this, unfortunately, is that currently the cryptography and the mathematics you need to do to build privacy on Solana isn't that optimal to run on the Solana blockchain. In other words, what this means is that all the computations that we need to perform don't fit in one transaction. And instead, it actually is spread out over 24 transactions, if I remember the correct number. Which is why it takes a little bit longer, because it has to do 24 transactions rather than just one. But let me move this to the side. Here we can see our top up was completed with sig blah, blah, blah. So if we take a look at that in the block explorer, what we should see is, if I scroll up a little, the key I generated for this workshop is DHS. So we should see DHS transferred 1 SOL. So let's check if that's the case. Let's go here. Paste in our transaction hash, or transaction signature rather. And if we look here at count inputs, we can see here, DHS had 2 SOL before, and it lost 1 SOL and a little bit more. This little bit more, as explained, is unfortunately because we need to do 24 transactions. And basically it has to pay the transaction fee for those. But what we can see is we lost, or rather we converted from our public balance 1 SOL to 1 private SOL, so to say. Cool. So before I move on, does anyone have any questions about this first part so far, which means setting up your elusive instance and creating a private balance?
Just to echo that as well, again, guys, please feel free to just drop any questions in the chat. I'm happy to tell Nico as the workshop is going along.
Okay, I'll take that as no questions so far. So in that case, we can, and as Joanna said, if you have any questions, you don't need to wait until the end. You can just write them in the chat. So we've created a private balance, or rather, we've just transferred 1 SOL. of course, what we want to check is if that one sol actually successfully arrived inside of our private balance. So the first thing we want to do is fetch our private balance and see if our money actually went where I claim it went. So let's say const private balance is, again, we use the Elusiv instance. That's kind of the, like I said before, the heart piece of the whole working with Elusiv. And we say get latest private balance. And again, we say what token type do we want. In this case, we want LAMPorts because that's what we just topped up. And then we're going to log that into the console. Let's try just that for now. And let's see if that works as it should. Oh, and I think I need to comment this as well. npm run send. And if everything goes well, it should hopefully log 1 billion LAMPorts. Yeah, I'm counting 9 zeros, so that looks correct. So basically it says, okay, we fetched our private balance, and as we transferred one sol, this is how much we have, 1 billion LAMPorts, aka 1 sol. Cool. But of course, what's more interesting is not just having this in our private balance, not being able to do anything with it. More interesting is actually doing something with it, which means, for example, sending it to someone. So in this case, let's actually say, let's generate a new recipient. Keypair.generate.public key. Again, this is fake money, so we don't really care if we send it to some random address here. And yeah, here with this little send helper function. Let's see how we actually implement this to do a private send. And for that, actually, let me pull up the top up as well, just so we have it on the side. So for the top up, the first step was Elusiv instance.build top up. So for send, pretty much the same. We say send is await elusiv.build send transaction. And yeah, we say how much we want to send, who we want to send it to, what token type we want. And then there's a couple of other parameters. Yeah, I mean, those aren't, again, same for as the top up. You have a couple of the options of like how you can make the send a bit more customizable and flexible. But for now, we just want to do a plain old send. So let's just leave those blank for now. Okay, and now we just say elusiv.send elusive transaction, and we pass in the send transaction we just built. And yeah, this purposefully, I put these side by side so you can see that here we don't sign. I'll explain why in a second. But yeah, if we look here, what our code should do is, okay, it should print our private balance again. Then it should check, do we have more than 0? I think it should say, yeah, okay, whatever. It should say 0.5 times LAMPorts per sol, because that's how much we're trying to send. And then it should generate the recipient, and then it should send to that recipient 0.5 LAMPorts per sol or 0.5 sol. And then it should, again, print out the signature. Or otherwise, it's going to, yeah, if it throws an error, then, All right, let's start running this. And unfortunately, same as for the, let me move this as well. Same as for the top up. This, yeah, takes, I believe it is 60 transactions to fully execute to verify zero-knowledge proof on chain, which is why, again, we're going to have to wait like a little bit longer than for conventional Solana transactions. But yeah, in the time that we wait, let's quickly compare, So like we saw, first step, building the transaction, pretty straightforward. Last step, sending the transaction, also pretty straightforward. However, here in the private send, we don't sign the transaction. Now, this might look a little bit weird at first because, with Solana or pretty much any blockchain, you're used to that when you send a transaction, you need to sign it because the signature is what proves that if you want to send SOL, for example, that SOL actually belongs to you because you're the one who generated the signature for it. However, the whole point of Elusiv and private sends is that it's private, which means if we would sign it, then anyone will be able to see, oh, this transaction here has Nico's signature on it, so that's how I know it's Nico's transaction. So for this reason, we prove, and that's why you need the top up step as well, that we own these private assets a little bit differently using zero-knowledge proofs. And yeah, zero-knowledge proofs allow you to stay anonymous, unlike signatures in this case, which is what's actually happening inside this build send transaction function. That's why we don't need to sign, because in this case, we prove it's our money through a zero knowledge proof. But yeah, that's a big claim. I just said this was a private send, but let's verify if that's actually true. So let's take the send, 5LL whatever. Before I go over, let me quickly just go here again. Okay, quick refresher. Our public key is DHS blah, 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 DHS. And yeah, here you can see in the top up again, DHS is our public key. And now let's look at the send that we just performed. Okay, so we can see, okay, I assume this is the recipient that we generated, CN4 whatever. He received his 0.5 SOL. He's happy. Now let's look for DHS. Okay, so on here, no DHS, so no one can see it's us. On here, no one else, nothing else. On here, okay, DHS, but that's just a substring of some other address. And on this page, nope, nothing. And finally, on this page, nothing either. So what we can see here is that, if a recipient would, he receives the funds, the 0.5 SOL in his public balance, then he'd be able to see in the block explorer, oh, okay, I received that 0.5 SOL in the transaction 5LL and HJ. And if you would paste that into Solana.fn, for example, and start looking at the public keys to see who actually sent him that 0.5 SOL, there's no way that using this transaction, he'd be able to determine that we, DHS, were the ones that originally sent it to him. So basically, we were just able to send 0.5 SOL to our friend while staying fully anonymous, which, in my opinion, is pretty cool. But yeah. Again, like after the top up just now, is there any questions about the send or Elusiv in general at this point?
No questions so far on my end, but of course, again, everyone, please do write any questions you have along. I appreciate for some this might be a lot if it's your first time seeing this. But yeah, please, this is a great opportunity to ask Nico as he's live with us today. But yes, please do that.
All right, sounds good. In that case, this was basically the warm-up, like the main idea of how you use Elusiv. But yeah, just since this is a hackathon this is a hackathon workshop after all, I want to give you guys, a little example of what you might be able to build with this, which is building private Solana Pay, so to say. Now, many of you have probably already heard of Solana Pay, but if you're like me, for me, I had always heard about Solana Pay, but I didn't know, the actual implementation details of it. So if that's you, here's a super quick rundown of what Solana Pay is. Solana Pay was developed by the Solana Foundation or Solana Labs. I can't remember which one, but by Solana. Basically, is a way that is a standard with which you can encode, transfer, or transaction requests. So essentially, the idea of Solana Pay is that if you're a merchant and you want someone to pay using the Solana blockchain at your store, it might be annoying, or if you're wallet as well, it might be annoying if one merchant says, okay, send a transaction, using a cross-program invocation, and the other one says, oh, don't do it like that. Please attach a reference key to it. And the other guy says, oh, please attach a memo to it. There's no standardized way to do it, and it would be really painful. So that's why Solana Pay was invented, which is a standardized way to encode transfer requests inside of URLs, meaning you can take that URL and either just give the URL to your customer, or you can encode it in a QR code. Your customer scans it and has all the information in a standardized way to be able to pay for your good. And what is all that information, you may ask? So here we can see it. Transfer requests have as information, again, the point of a transfer request is to request the transfer of SOL or SPL. So the first parameter that they have is the recipient. I mean, pretty straightforward. Who should you send the money to? The amount, how much money should you send? The SPL token, what token should be paid in? Reference, I think, in my opinion, this is the most important part of the Solana Pay spec. The idea of reference basically is it's a special reference key that you should attach to your transaction, to the transaction that you will send to the merchant. And you might ask, well, what's the point of adding a reference key to a transaction? And the point of that is, imagine you have some really big business. Let's that makes tens or hundreds of sales every minute. Think on the scale of Amazon.com or something like that. And now let's say in Amazon.com, you're the Amazon.com server. You have 2 people currently checking out their cart. One person has a soccer ball in there. Soccer ball costs, let's say, $20. The other person and person B has a baseball bat in their cart. Baseball bat also costs $20. And so normally what you do is you'd say, okay, person A, please send me the $20 to this Solana address. Person B, please send me 20 USDC to this Solana address. And then you receive 20 USDC to your Solana address. But now you have a problem because you received 20 USDC, but how do you know, if that was from customer A or if it was from customer B? That would require them having to give you their public key and a bunch of other more complicated stuff. So for that reason, the way Solana Pay solves this is by having the reference key. So there, what the merchant does is he says, okay, customer A, when you send me your $20, please attach the reference key ABC, for example, right? And person B, when you send me your $20, please attach the reference key DEF, blah, blah, blah. And in that case, when you then receive the $20, you check the reference key and you can see, oh, this is reference key ABC. Nice. Since I gave reference key to person A, I know that I can now finish the checkout for person A, but I'm still waiting on the $20 from person B. So that's the point of the reference key.
Hey, Nico, sorry, just to interrupt. Roman asked, can you make Elusiv-based confidential transactions using Phantom mobile wallets in combination with a page in its web view?
So you can make Elusiv work with pretty much any wallet that you want. So like I showed in the demo or in the code earlier, the only thing that you need your wallet to be able to do, or that you need whatever you want to integrate it with to be able to do, is you need to be able to sign messages. So for example, on our web app, we have a web app as well if you want to try it out without development. On our web app, you can use it together with Solflare, Phantom, for example, Backpack, and pretty much any wallet that supports signing messages. So yes, you can use it with Phantom. You mentioned something about the WebView thing. To be honest, I'm not exactly sure what Phantom WebView is, but I'm pretty confident that Phantom in their WebView thing also supports message signing. Yeah. I hope that answered your question. If not, feel free to follow up.
All good there. Roman said thank you for the explanation.
Cool, perfect. Okay, in that case, so reference keys used to identify payments with the same amounts or just identify payments in general. Next, label and message. These two aren't that important. These are usually only to show what's in the UI. So these don't get really encoded in the transaction. Label is usually just what's merchant you're buying things from, and message is what item you're buying. So in our example from before, label would be Amazon and message would be soccer ball, I think it was. And yeah, memo. I'm sure many of you have heard of memos before. Memos are just little short strings that you can attach to your Solana transaction, and so little messages that you can attach, and also what the merchant can request you to attach. Yeah, and redirect, that's not that important for the sake of this demo. So yeah, this is how a Solana transfer request works. And let's go and try to make it work together with Elusiv. So we go here, Solana Pay demo. The cool thing is, for most of the Solana Pay stuff, Solana offers an SDK at Solana/Pay, which basically takes care of all the encoding and decoding URLs and whatnot, so we don't need to do that by hand. But of course, this Solana Pay SDK and Solana Pay in general expects normal Solana transactions. So let's see how to make it work with private Elusiv transactions. So for starters, let's say let's try to program the example that I said before. So let's say here is what our merchant does. So let's say merchant. This is the code that our merchant would execute. So first, he would have to specify his transfer request. So for that, he'd say, okay, recipient that I want the money to be transferred to. He generates some public key, or he probably already have a public key, but for the sake of this example, it's just generating a random one. Then the reference key that I want to use to detect that the transaction is from the customer, I'm going to generate a new public key for that as well. And then for the memo, not really necessary, but why not? We'll say, oops, should be this. We'll say Solana Pay X Elusiv, for example, or let's call it private Solana Pay for the little message that'll be attached to a transaction. And for the amount, let's say, I don't know, we had 1 SOL in our private balance before. We sent 0.5, I think. So we should have 0.5 left. Let's say like 0.1 or something like that. Yeah, 0.1 SOL. Okay. So then to create the Solana Pay request, our URL that we want to send to our customer so he knows all this information in a structured way, we can say, okay, request is create request. Then we pass in the recipient, the reference path, the reference key. I think I put in the wrong order. The amount, the reference key. The label, again, label, not that important. That's okay. In this case, it was Amazon, I believe, and the item that we're buying is soccer ball. And finally, the memo that we created for ourselves. Cool. So yeah, we've created it. So basically, to summarize, our merchant said, okay, I have the recipient where I want to send the money to. I want to receive 0.1 SOL. I want the transaction to have the message private, the memo private Solana Pay attached. And I want it to have this reference key of my choosing attached as well. Cool. So next, he takes this request. This is, remember, request is a URL / or a QR code, for example. So he takes this QR code, he shows it to the customer. To our customer, he scans the QR code, gets the request, and now it's up to him to respond to that request. Now let's say we're the customer and we're shopping on Amazon, but big tech, data privacy doesn't really add up that often. So instead, we don't really want to leak our public key and all our on-chain information to Amazon. So for that reason, we say, okay, let's use Elusiv to pay for this transfer request. Yeah, let's use Elusiv so we can stay private, but still are able to buy our soccer ball. So we say, okay, the parameters that we want in the request. To parse those, again, we use Solana Pay library. We say parse request, the request, not the recipient, the request. Yeah, that should give us the parameters. Nice. And next, pretty straightforward. We build the send transaction. So we say const send transaction like before. Elusiv.build send transaction. We pass in the amount. No, we pass in params.amount in line ports, because remember, these values are only known to the merchant. We, as the customer, we don't know these values. We only have what we get in params. We have the amount, the recipient, params.recipient, the token type, line ports, the reference key, params.reference, the memo, params.memo, and this one's not needed. And finally, is Solana Pay transfer true? Because yeah, we want it to be Solana Pay compatible. Cool. So yeah, we've built our.
Nico, sorry, before we move on, just a quick question from DJ. Can you take Elusiv's SDK and create your own wallet to use ZK transactions?
Yeah, you absolutely can do that. You definitely could do that. You could take the Elusiv SDK, and then basically you could do whenever you have funds in your wallet, you just automatically top them up to private balance. And in that case, yeah, you could make it that from the UI point of view of your user, he always has private balances. So yeah, definitely possible.
Yeah, they said awesome. Thank you for that.
Sweet. No problem. So yeah, next we're the customer. We've built our send transaction, according to the parameters that the merchant wants to have. And then now the last thing to do is to send it off. So for that, we do elusive dot, actually, let's say const result equals elusive dot send elusive transaction, send transaction. Okay. Now, before I continue, let me hover this thing as well. Is there anything wrong with this line of code? Like, will this return what I want it to return? If anyone has a hunch of what I might be doing wrong in line 43 here. If not, okay, let me give a little hint. If I would say console.log signature of the send is res, yeah, would this print out the correct signature, or would I need to change something in my code for it to print out the signature that I want, that the send was executed with?
If anyone has any ideas, yeah, again, please free to drop them into the chat. Ooh, I see Roman typing. Oh, no idea. I'm not a dev. No worries.
No worries. Okay, yeah, no worries. In that case, I'll reveal the mystery. So yeah, for those of, yeah, so basically what I'm doing wrong here is usually what I need to do would be to await. Because in that, yeah, because by default, send elusive transaction is asynchronous, or yeah, basically we get a promise back, but what we want is we want to wait, basically, essentially, yeah. So for those of you who might not be developers or who might be a bit more new to developing on Solana or with TypeScript in general, a promise basically just means that essentially a promise says, for example, here we get the signature back, and what a promise says is this function is going to continue to run in the background and will at some point return the signature. But if we want to actually wait for that to happen, we need to use this little await word here. Otherwise, if we do it like this, it's just going to run in the background. It's going to continue running in the background, but it's never going to tell us when it's done. However, in this case, that's on purpose. And the reason that is because if we would await for our send to complete here, we're still on the customer side of the code, right? And usually when you go shopping, at the supermarket or something like that, or you go buy a coffee, the way that usually works is, let's say you pay with a credit card, you tap your credit card, and what you usually do then is the merchant waits for your money to arrive, not you. So it's not you tapping your credit card and then you open your banking app or whatever, you show it to the merchant, you say, see, look, $5 was subtracted. No, it's the merchant that waits for your transaction to go through on his end. So that's what we're going to do in this case as well. We're not going to use the Elusiv SDK to wait for the transaction to go through. We're just going to send off the transaction and hope the merchant can parse it correctly, even though he doesn't even know what Elusiv is. Again, here we're on the merchant side again. And what a merchant can do is Solana Pay has a nice little function, config called await Solana Pay confirmation, where you pass in what I mentioned before, the reference key, and a connection object, and you get out the signature. So yeah, let's try logging that.
Oh, Nico,
yeah,
we just had some couple of questions about that. Satyam asked, is there any other way to do it other than await?
To do what? To await the prompt, to await a promise to confirm, I assume is the question.
Satyam, if you don't mind, if you could just clarify the question. As Satyam is doing that, we do have another question as well, which says, essentially, what does TypeScript allow me to do that Rust won't? Like, what are my trade-offs?
Yeah, for sure. So, I think saying what TypeScript versus Rust allows you to do on a grand scale would probably exceed by far the frame of this workshop. But in the context of Elusiv, let me summarize a little bit quicker. So Rust basically is a language that's a bit more performant than TypeScript, but also a bit less flexible in the sense that, yeah, and basically most apps on Solana basically have two parts of it, right? The first part is the actual smart contract, or the, as it's called in Solana, program that runs on the blockchain itself. And this is usually written in Rust, exactly for the reason that it's, yeah, a bit stricter, which can be good in some cases, and more performant. However, most front-end stuff, or most times when you actually talk to the blockchain, most clients are written in TypeScript. And so basically what this SDK that I'm demoing here allows you to do is it allows you to easily basically communicate and send transactions using the Elusiv on-chain program. And if we had written that in Rust, which would definitely be possible as well, the disadvantage of that would be is that in most cases, when you want to talk to the Elusiv